All right. So what is Data Explorer? Let's start with that. So factually, Azure Data Explorer, it's a kind of newish product. It has been launched in 2018 as a general availability, but it has been used internally at Microsoft for 5 years at least. So since 2015 about. It's the foundation of multiple Azure services that you probably know. If you know Custo, you probably heard about Custo in relation to Azure Monitor. So it's the query language for Azure Monitor, log analytics, application insights. So all the Azure Security Suite, Sentinel is using it. If you know about Azure Time Series Insights, it is part of it as well. PlayFab might be less popular, but you might have heard about the Microsoft Connected Vehicle Platform. It's using Custo underneath as well. It's a Microsoft proprietary technology, so it's not based on an open source package or distribution. Basically, in a nutshell, it's an analytical database. So the data is ingested. So often people ask me, can I look at the data lake with it? Yes, you can, but that's not its strength. Its strength is about ingesting data, analyzing it afterwards. And it's highly optimized for ad hoc analytical queries capabilities in general. So we'll look at different scenarios, but yeah, basically it's analytical database. I'll extend the invitation from Jared. If you have any questions or want to participate, please feel free to use the chat window. One of the needs that we see for big data in a modern business environment is the growth of data. You've probably heard about the 4 V's of God, volume, volumetry, velocity, etc. So if we go back in time, and when I started my career, a while back ago, we had traditional systems that were having a very rectangular view of the world, such as ERPs and CRMs. So you had tables with rows and columns. And typically it was in the megabytes range, maybe gigabytes in the biggest deployments. Then came Web 2.0, where things started to much more volume, much more velocity in terms of how the data was created, generated. And we started to have stuff that wasn't fitting so much into a rectangle anymore. So we had web blogs, we had marketing information. And then we got to the big data world, where we have stuff like click streams and senses and audio and video, log files. All of those are generating huge amount of data every day, and they don't conform to this rectangular view of the world anymore. So a couple of patterns that we see is that we have a lot of free text data in those, and often we have an happen-only pattern. And those are the patterns of the data that ADX or Azure Data Explorer is exploiting. So if you studied a bit of database systems, you know that there's always trade-offs and choices that you need to do when you design a system. So ADX is not a transactional system; it's a big data analytical system, and it takes advantage of those patterns. Also, on the business side, what we notice is that new decisions need to be taken daily. You've probably noticed that in your business. Decisions are decentralized, so there's much more decision makers. And for that, they need data to take good decisions. Otherwise, just gut feeling, and that doesn't work anymore in the world we're living. So this is the context where Azure Data Explorer was born and trying to live. Let me start with a demo, and then I'll dive a little bit more deeper into why and what. So let me get into my Edge browser. So just to show you how does it look, this is a cluster, an Azure Data Explorer cluster. It's not started, so I won't do the demo on that one, but just wanted to show you how it looks like. Basically, it's a cluster, so you have many nodes. In this case, I got 2 nodes. It's completely transparent on the type of VM it's using. So in this case, it's a standard V12, V2. So you got different types of nodes, and you got number of nodes. You can go up to 1,000 nodes if you want to. And you have different types of nodes. Some a bit like Azure Databricks, if you know Databricks. Some will be memory or storage optimized. Others will be compute optimized. So it depends on your workload, what you favor. And that's about it. Otherwise, there's a bunch of things that I won't talk about today, but you get VNet integration, encryption, and that type of thing, like more enterprise features that I won't talk about today. But let's look at the querying capability, because that's where Azure Data Explorer really shines. So I'll start with a demo that start with a welcome. Start with a demo looking at the GitHub data. So if I look, this is not my cluster. It's a demo cluster that I have access to. It's a big cluster. I think that has 12 nodes. So it has a lot of RAM and there's a lot of SSDs. Our ADX thrives on RAM because it's basically an in-memory database or local cache database, I would say. So it needs SSD. Otherwise, it can work with cold data, but it's really not as efficient. So the bigger your cluster, that's what I was talking about, storage optimized versus compute optimized. So the bigger your cluster, the more you can, the more cache you can have. So the more you can query data, big data. So that's what it's about. Let's look at this table. So this GitHub event, it's data we pulled up from GitHub, obviously. So it's, I think it's like 1 billion records. Yeah, so about 1.2 billion records in this table. That has already been ingested, obviously. So it is inside the database. If you look on the left-hand side, you can see got a couple of clusters over there. If you squint a little, you might think that looks like SQL. It is kind of SQL. It's a bunch of databases with tables underneath. So that's the table I'm interrogating. And that table has columns. So it might look a bit like SQL in that respect. Let's look at a couple of those rows. So that's the scheme of the table. You can see IDs, type of events, but you can see that although it's a table rectangular format, there's some JSON in it. So it's not only columns and rows. You can see there's more complex data. So there's semi-structured data over here. And I also, do I have some unstructured data? Don't really have text in this case, but I could have text that I could use to mine. I've been using Custo. So that's the Custo language. Just a quick, very, very quick 101 of Custo. I know that's one of the first barrier of entry for Custo is it's a new language. It looks weird because I've never seen it. Like every new language you look at, it has a funny syntax the first time around. I can promise you from experience, if you know SQL, you can spend 2 to 4 hours Friday afternoon and you'll be an expert in no time. It's pretty easy to learn. It's just a question of what concept correspond to the other one. We didn't make a new language for the sake of it. It's I would say it's much more efficient to do analytics. So if I demo that, if I take that table, it's basically you can look at that as a data flow. So I take this this table. I can do like I did above. I can say, okay, I'll just take the first 10 rows. Maybe I want to do a projection, so I just want to project the ID column and the actor column, and I can do that. I'm just doing Shift. You don't see me, but I'm just doing Shift Enter. Alternatively, I could click around there. So that's one way of doing that. I could say, okay, but do a where clause where I don't know, ID is bigger than what is that 9 billion. So 9. Let's try that. I shouldn't improvise it in demo. Okay, it works. Okay, so you can look at that as a pipeline, but under the cover, Custo basically takes that query and optimize it and does a query plan and send it to different nodes. But just to give you like a quick idea of what Custo is, just like a pipeline of instructions. I find it very intuitive to do analytics because it's like telling a story. You take the table, you predict those things, you do a where clause, and then you take a limit 10. If you would translate that into SQL, that one wouldn't be too bad. But once you start to do aggregation, you start having group by that. I always find the order of the instructions a bit confusing. So I find Custo more intuitive and more productive. Custo does understand SQL, though. If you do those 3 dashes, you can do a top 10 on that table and would basically translate your query into Custo. And the other way around, you can ask if you're learning Custo, say explain what that query means, and it will translate it for you. So you see it does it in a funny way, like it doesn't translate the star and a star. enumerates the field, but basically translate it for you. The reason we do that is not for you to learn Custo. It's more for plugin reasons, because the T-SQL ecosystem is vast, and Custo is basically leveraging that. So there's a bunch of things that connect to Azure Data Explorer using T-SQL instead of Custo for that reason. So if we go back and you look at a sample of the rows, we can see those rows. You can see that the column is JSON, and what I'm going to do here is that I'm going to get into that JSON. So I'm going to say look at GitHub event, where the repo column contains Custo. So I want a repo on GitHub that had Custo in its name or somewhere in its metadata. Then I want to extend. Extend is basically creating a new column, a calculated column, if you will. Take the name and project the name under repo. So basically that little thing here, like that sub property inside the JSON, cast it to a string and compute the distinct name on that. So how long will that take? That took way under 1 second. Actually, most of that time, if you look at the stat of the query, it's 0.03 seconds of execution time. All the rest of the time over here is probably latency between my computer sitting in Montreal and the data center in the East US or wherever that cluster is. It's in the West US, so on the West Coast. So far from you. It's close for you, but far from me. So if I go back here, I see all those repos. If I look at all the repos that have been created between the date of 2017, 1st December, and 60 days later, so you see 60 days, so you see this very convivial syntax. Then I do a summarize, like a group. Obviously, I'm going to count all those things by bin of 1 day for the creation ad. So I'm basically bucketing the time into 1 day's buckets. And then I do something special you probably wouldn't see in SQL. I actually get into rendering capacity inside the query language. I say, take that table and render it as a time chart so I can see what is going on. So it's interesting. You can see there's lots and lots of repos being created every day, but you can see kind of a pattern. So that's interesting. You can see the week pattern. You can say 5 days and a weekend coming in. I don't know what was going on. That's Christmas. That's why there's a bit of a drop there, then it comes back. So you see that I'm exploring my data very, very quickly, very easily. Again, I'm going to look at the repo containing Azure, projecting the repo name again, taking the first 50 columns. So I get all those the repo there. Let's look at some aggregation I could do. First, I might want to look at the top 10 popular repos by watch event. So if I look at, I put in ellipse over here because I was supposed to write it directly. I'm not sure I remember the query. So I want to look at the top 10 popular repos. So maybe I do a summarize count on the number, or maybe a top 10 by count. That works. Very bad idea to improvise in the demo, so don't try that at home. Let me quickly move forward. This one will be a bit more complicated. So I want to look at the top 5 popular repos, but using a more complex weighting system to see which one is more popular. So what I'm going to do is that I'm going to use variables, something quite original to Custo. So I do a let instruction over here. I say watch repos. I'm basically creating a table on the fly, or it's a data set on the fly, if you will. So I take the GitHub event table. I filter all the watch event. So that's a type of event you have in GitHub. I go and pick up the repo name. Then I do a summarize on the count, so the number of those watch events by repo name. Then I do the same thing, but for issue comment event and issue events. I'm basically looking at repos that have not only that a lot of people are watching it, but a lot of people are collaborating or interacting with it by posting issues. And then I'm going to join those 2 tables here, doing a join. Then I'm going to calculate this popularity column, mixing a number of watch events, so that that aggregation I computed here, and the issue event that I computed here, giving it a respective weight of 30% and 70%, and taking the top 5 and rendering it as a bar chart. And take a few seconds to compute, and boom, get Kubernetes, quite popular repo, and then Microsoft VS Code, woo, top 5. We found a metric, we're in top 5. Apache Spark and Rust, if you know Rust, very popular and upcoming language. So you can see that I could compute something relatively complicated on billions of records in a few seconds. So that's quite fast, and it's a good way to analyze and explore data. So the thing I wanted to show you with this demo is first the language, so that we get this out of the way. Then I wanted to show you how fast it is to do aggregation and very simple queries and graphs with Kusto. If there's any question, gentlemen, just stop me. Otherwise, I'll assume there's none.
No questions right now.
All right. If you're wondering why is it called Kusto with a K, it's in the honor of Jacques-Yves Cousteau, the French explorer of the sea. While Cousteau, Azure Data Explorer, is the explorer of the sea of data. So that's why it's called Kusto. In terms of momentum, Cousteau, I would say Cousteau is probably the best well-kept secret at Microsoft Data Analytics. We don't do a very good job at advertising it, although that changed a little bit last week. If you participated in the launch event of the V3 of the query engine of Cousteau, there was a big event, 3 hours on Wednesday. If you're interested, the content is available online. But if you look at the momentum, it's available in all regions of Azure. So it's considered like a foundational service because it's the foundation of Azure monitors. It has to run everywhere. It has close to 2 exabytes of data under management under Cousteau. So that's both internal to Microsoft and external to customers, clusters. Talking about clusters, there's about 1 million cores running Cousteau. I've seen the stats somewhere that it's 2 to 3% of Azure is running Cousteau. So lots and lots of VMs running under Cousteau, basically. 30 petabytes of data ingested every day, lots of queries, and lots of distinct users. So although it's not very well advertised, it's a very well used product, and it brings a lot of productivity. Internally at Microsoft, we use it a lot to analyze the telemetry we get from Azure and from different products, basically. And similarly, I see the different customers doing that. Talking about that, let's step to the second section of my talk. I wanted to tell you about the 3 main scenarios where Cousteau shines. This is a slide done by a colleague of mine to try to explain the some complexity we have in Azure in terms of number of Azure data services. So we have a lot of data services. They typically all sit on over the Azure Data Lake service. So that's your foundation. Your data lake is where you store all your data, and you ingest that data to do different things. Shall you do data engineering or time series analysis or reporting? You always start with your data lake in a modern architecture. You see Cousteau is sitting here in big data exploration and time series, and you probably see other products that you know, like Synapse, Databricks is present over there. So all those services are doing a lot of things in common, like they all treat data. They can all store a tuple. They like a data row somewhere. So why bother about ADX? What does ADX do better than the other one? So where is ADX better at than the other services we have? Where does it shine? Those are the 3 main scenarios I'm going to talk about. So first, data exploration. I talked a bit about it. Let me maybe frame what I mean by data exploration. I mean that you don't necessarily know what your data is about. So compared to a data warehouse scenario where you're going to prep your data, you might pre-compute some aggregates. In the case of data exploration, you don't know what you're looking for. So you're going to do what we call ad hoc queries. So you're going to do queries that the system doesn't know you're going to do. And ADX is especially good at that. It indexes everything. As you've seen, it's very quick. There was nothing cached on what I showed you. The data was cached on the nodes, but the queries were not cached. I was not using underlying materialized view or special indexes. The data was simply ingested into tables without any index designs. So you don't even have instructions for indexes in Cousteau, and it runs that fast natively for a reason that we're going to see a bit later. So that's data exploration. Coupled with that, it's very fast at ingesting data, and that's why it's a very good candidate to do what we call real-time analytics, so where you ingest data in real time or near real time, and you can keep querying your data in near real time. And coupling that with data exploration, there's a lot of customers using it to do monitoring in the broader sense, not only monitoring of Azure, but monitoring of their business operation. So monitoring of telemetry from IoT devices or from system in the field, from cells, from different branches. If you want to pick up anomalies going on inside your operations, you might want to do that to get real-time ingestion and then to be able to quickly run a couple of health query on your data. Or when some trouble appears, if you want to know what is causing the trouble. So often it's one thing to know about a problem, it's another thing to discover why a problem is there. A great demo that I have, but I won't do tonight, it's a demo about troubleshooting a problem in Office 365 using logs that we have. So it's we're able to narrow down an issue by just looking at the logs. And finally, the third scenario where it's really good at, it's with any fast-moving data, and where you have time series. Again, time series, what do I mean by that? It's basically when you have, well, temporal data, so data that falls into time. So you have actually a time column somewhere and other data following it. But time series is typically where you want to partition your data by some elements. So typically in IoT, you want to have a time series per device, for instance. So you want to compare the behavior of different sensors of different devices. And when you have many such devices, it's really hard to do. So I got an example. Actually, I got an entire demo on time series. So let me jump on that. So this is my second demo here. So that's a different cluster, but basically it's still not mine. So let's look at a couple of time series. Actually, you can do that in the online doc. I just took the online documentation and did a quick demo script with that. So if I look at the first time series table, it has 600,000 rows. If I look at the sample of that, it's a very simple table. So there's a timestamp column, there's a browser. So basically that's telemetry looking at different browser version with different OS version in different countries. So one thing that could be interesting to look at is the OS version over time and the count of that to see how popular an OS version. That's pretty old data. As you can see, it's 2016. So what I'm doing here, I'm doing a make series operator. So that's going to create time series, and then I'm going to render it in a time chart. There's just 3 time series here. There's just 3 OS slash, well, just 3 OS basically. I'm going with OS version. But let's look at the data under that graph. I look at the table. This is a time series in Custo. So the time series are represented as a vector basically. So you can see that. You can see that over here. So what I did is basically I said take the count the number of occurrence for a given OS version. Do that by slices of 1 hour, and put that into a time series basically. So what it did, it created this num column, which is the count, and another column timestamp, bucketing it by buckets of 1 hour. So some things I could do in terms of time series, I could want to filter using what's called a FIR, like a finite impulse response. If you've ever done electrical system, you might know what I'm talking about. So let's look at just one of them. So you can see the blue line, if you can see colors, blue line is the original signal, while the orange line is the filtered signal. So I used filter with 5 components. So basically looking at 5 data points behind to do a filter. So that's one thing you can do with time series. Let's look at another one. I got another time series. I won't look at the table per se, but you can see that it's kind of a signal that's sort of regular with some noise. Then it kind of gets into to a bigger slope. If I do a linear regression with that, which I can easily do using the series fit line, it's going to try to fit the line into that signal. Not very useful because obviously the underlying signal is not purely linear. It's kind of bilinear. And that's what I can do with the series fit two lines, where it's going to basically try to find two lines that fit the curves and the best breaking points. This is very useful when you have signals that break at some point. So if you have, if you're looking at, for instance, if you're looking at the VMs, if you're looking at the CPU usage, might be stable for a while, then it might run away or something. Same thing with RAM, same thing with devices in the field. So that function is quite useful for time series analysis. Another example, if you look at this other time series, if we look at it over time, you can see a bit like the GitHub example that we've looked at. You can see that there's a periodicity or seasonality that we'll talk about when we talk about time series. It would be nice if I could detect that pattern. I can do that using the series period detect, so basically detecting a period of time, giving it some range. Okay, go between 0 and 14 days. And find me two types of period. I'll spare you the rest of the query, but basically it gives you the score. So it's, of course, it's not a precise science, but it gives you, I see a pattern for 7 days and I see a pattern at 1 day. So basically it sees a pattern for every day. There's an up and down. And at 7 days, it sees a seasonality as well. So that's useful, of course, to when you look at data, to look at what type of seasonality you have. And finally, if I look at this last bunch of data, and that's probably for me driving the point of the power of time series analysis. If you look at that data, it's basically, again, timestamp and some value like data read, whatever that means. But you got 3 other columns here that basically represent the source of the data, the location, up and DB, whatever those are. They just signify, you can see that as a, if you take those 3 keys together, they basically represent the server or device ID. So what I could do, and what we do traditionally, is look at that as one time series. And I look at the data read, and you can see, yeah, okay, there's some pattern, but otherwise it's pretty stable in time. And the reason is because I'm looking at the average. In this case, I'm not doing a count over time, I'm doing an average. And when you do an average, if you've studied a bit of statistics, you do get some information, but you burn a lot of information, or you delete a lot of information by doing the average. So what we could do instead, and we're going to do that here, is to look how many time series could I build if I look at the, as I said, as those lock up and DB keys as a compound key. How many time series would I have? I would have like 18,000 time series. So what I would do here, and with the time I'm doing here, I'm just looking at that curve with a bit of a narrow time period. But if you look at what I'm doing here, I'm basically building a time series with average, the same thing that I did above. But instead of just doing the average, I'm going to do that, but segregating it by lookup DB. So I'm going to create a time series per those keys. So basically 18,000 time series. Then I'm going to do a linear regression or a linear fit on those time series. I'm going to compute the slope. If you remember your mathematics, y equal mx plus b. So the m is the slope. And I'm going to look for the top 2 slope of those time series. So basically, I'm looking at time series that crashes the fastest over time. And I'm going to render that. Again, I can run that in just a few seconds, despite that I'm analyzing 18,000 time series at the same time, and I find those time series that crash very fast over here. If I could do that, a bit of a change here, I could do a top 5, and I would have 5 time series going on. But not very nice, because it's all confused on the screen, but basically you see, you get my point. Something interesting as well could be that, okay, now that I found a problem, basically I found either servers that go down or telemetry that stop happening, then I could look and please identify those servers / devices / whatever, then I find that, okay, it's log 15, 37, etc. So I found the problem very quickly by doing this time series analysis. And so that's something you could do in Python or in Spark, but as you can see, you can do it extremely fast in Cousteau. And because you can do it extremely fast, you can iterate very quickly. And also you could automate that so that you could run that query, say, every 5 seconds or every minute. That was for time series. Go back to my presentation. Still no questions? I assume that I'm crystal clear. So, question you might have: why is it so fast? So why is this engine so fast at doing something ad hoc, at ingesting data so fast, and at computing different operation on time series? So the ADX deployment model is a cluster, as I mentioned. Actually, there's two clusters, but let's just look at the query engine cluster. So there's a bunch of nodes. The data is sharded or partitioned into shards, typical pattern you've seen, and a node will own a couple of shards. So far, so good. Nothing super special. A lot of systems work like that. Synapse SQL Pool works like that. Databricks, to an extent, work like that, although it doesn't own data, but it caches data that way. So what's unique about ADX? Just put a little nomenclature at the top. So we got cluster databases, table extents. So basically, you have a cluster that owns a bunch of databases. Each database can have many tables, and each table will have a bunch of extent. Extent is a synonym for shards in Custo. So the thing that is unique about Custo, well, not unique, but specific characteristic, it's columnar. Each node is, each shard is columnar. So it's basically stored in columns. Those columns are compressed. It's fully indexed. It is segmented. Each segment has a statistic. And probably the most important one is that it's read-only. So it's sealed, if you will. So nobody can play with it. So once you created the shard, it is read-only. So you can delete it, but it won't be overridden. Because of that, ADX is able to do tremendous optimization because it doesn't need to rely on a transaction coordinator. It doesn't need to rely, did somebody touch the data since the last time I cached it? And it can scale out the operation. So there's no central node controlling what's going on in the cluster. So because of that, it scales linearly. So the fact that it's sealed is very important, but those other factors also influence the way the indexes are used. Because they're segmented and there are statistics attached to every segment, it's able to skip the reading of a shard. So in the business of databases, nobody writes a for loop faster than the other. I think that has been commoditized and everybody figured out how to loop through data. The game is about how much data I look into when I run a query. So if I can look into less data than you do, I'll be faster than you. And the way that Custo is able to do that, it's because all of its shards are segmented and each segment has statistics. So if I'm looking for, say, a person with an age greater than 40, and I know that that shard contains only people with the age greater than or less than 30, I won't even open that shard. So that metadata is stored separately. So it's able to quickly skip a bunch of shards and answer very quickly because of that. Otherwise, the data is cached on SSDs and RAM, as I already mentioned, and probably not responsible for the speed, but the extents are aligned with time, so that makes it very good with time series and fast-moving data, because typically in a Custo cluster, you'll have data you ingest in real time with a certain period of retention. So maybe after 3 months, you don't want to query your data anymore, so you want it to drop into cold storage. And because the extents are aligned with time, Custo can easily say, okay, that shard is no longer loaded into memory, and I'll make place for the new shard that just got ingested. If you look at the different query or different scenario, it's ADX ingesting, doing a query, or ingestion, actually, sorry. So if you look at the ingestion of, sorry. So it's a real-time analytics scenario I want to look into. I just want to here to drive the point that, because sometimes people say, yeah, but Spark does that as well. Actually, Spark does something slightly different. Spark is actually faster than ADX in terms of response time. So it's really near real-time. It's sub-seconds if you tweak it properly and you take a big enough cluster. While Custo will achieve ingestion in seconds, maybe 1 second if you take a very large cluster and you tune it properly. But what it does is that ADX does ingest the data, and you can query your entire data set. While Spark, if you know about structured streaming, It's basically computing on the fly an aggregated, a predetermined aggregate, while ADX is always working in ad hoc fashion. So I'm not saying that one is better than the other, but it's a different scenario, so it's not really feasible to compare each other. So one, I would talk more, for ADX, I would talk more about real-time analytics and ad hoc real-time analytics, while the other one is more streaming and real-time transformation, more akin to what you have in Azure Stream Analytics, Apache Flink, or structured streaming in Spark. If you look at the ingestion model, why is it so fast in ingesting? If you look at Event Hub ingestion scenario, that's quite typical with ADX. You'll have Event Hub partitions. In this case, I don't know if I put it properly. You have up to 32 partitions. Don't quote me. I'm not sure if it aligns with that. Different nodes will read different partitions and ingest the data and create an extent out of it at periodic time. You can, as I said, you can go as low as a few seconds, and then everything can be done in parallel because there's no coordination needed because it's all read-only. The only coordination happens when the extent is created. That's communicated to the entire fleet of nodes on the entire cluster. That allows it to go really at a linear scale. So it doesn't need to communicate. It doesn't need to lock anything because it's just ingestion. There's no transaction involved. It is atomic in the sense that your data will either be completely ingested or not, but it's just at the node level. So because of that, you get no lock, no latches, no contention. And that's why it's fast. So I'll go a bit faster on that because I'm running out of time. For time series, I think it's just building up on the first two items that we discussed, the fact that it's good at ad hoc queries and the fact that it's good at real-time analytics. And because of that, it's very good at time series. Plus, it has a bunch of built-in time series functions that are optimized for them, as we've seen. Now, the other side. So I didn't want to leave you with thinking that ADX is the best thing since sliced bread. It's good at the scenarios I told you about. It's not good at everything. You shouldn't put it in that for everything. So let's look at one slide at what it's not good at and where you shouldn't use it. First thing, a long-running task. It's not really good. Actually, it's not good at all to do long-running tasks. So if you want to do a super long-running query, as you've seen, queries are pretty fast, but if you do like a super complicated aggregation on zillion and zillions of rows and you have a tiny cluster, it's going to take a bit of time. If it goes above a few minutes, it might be unstable. If it goes above an hour, there's a hard timeout on 1 hour for running a query. So not good at long-running tasks, as opposed to Spark that you can run stuff for weeks if you want to. Data engineering, it's very good at doing real-time processing, something I didn't demo, but when you ingest data in real time, you can do transformation on your data in real time. But it's not really good at doing that for batches. So if you take an exabyte of data and say, hey, let's flip it around or let's rewrite it, something you could do very easily in the Spark cluster, redistribute the data somewhere else in a data lake. ADX sucks at doing that because it's not good at long-running tasks. Anyway, it's probably wasteful to ingest data and index it if you just want to transform it. So not a good candidate for data engineering or batch data engineering. Something I didn't mention, but it cannot delete data and cannot update data. I mentioned you can swap or delete extents, but you cannot do that at the row level. There is something to do that for GDPR scenarios. If you want to eliminate data for a specific user, you can do that, but it's very compute intensive. Basically, re-ingest all the data that needs to be re-ingested. So it's going to eliminate a given user or given data. Basically, you give it a query, and it will eliminate all that data from your cluster, including cold and warm storage. But otherwise, you can delete. So not really good at data warehouse scenarios. You don't have any row-level transactions, only at the extent level. So you can switch extents around, but you cannot do that at the row level. So it is a database, but definitely not a transactional database. It's really in the analytical corner of the spectrum. It's not good at doing streaming as I define it, like at doing pre-compute aggregate on the fly and pushing it back to Event Hub, for instance. There's no output to Event Hub. There's output to Data Lake, but not to Event Hub yet. And finally, training machine learning models. It's not really good at doing that. It does a few for clustering, and you've seen linear regressions. But if you want to do deep learning, deep neural networks, that type of thing. It's really not the platform to do that. But as with Azure Synapse, ADX can run models, ONNX models, or any Python models. I didn't mention that, but you can run Python in a sandbox within ADX. So it's good at that for doing scoring, but it's not doing that training. So sometimes I like to think about those different services. I just put those three, Spark, Synapse SQL Pool, and ADX, as something. What are each of those specifically good at? SQL Pool, obviously, for all the modern data warehousing scenarios. Spark is good at data engineering, complex data processing, streaming, machine learning training in parallel when you need parallel machine learning training. ADX, as I said, the three main scenarios: data exploration, real-time analytics, time series exploration. And of course, there's stuff where it crosses the boundaries. So, the ADX can serve APIs, so can Synapse. Which one is better depends on the scenario. And if you look at high level, yeah, you can do analytics on petabytes of data with all of those, but really different scenarios. So really look at the specific scenario that you or your customer, if you're a consultant, want to achieve before positioning a service like that. I would say with the only caveat, of course, that you or your customer might not want to learn 10 or 12 Azure service. So sometimes it makes sense to do something in a suboptimal manner just to leverage the skills that your team has. And with that, that completes my presentation. So does anyone has questions on what we discussed so far?
So when it comes, I actually have a question. Hi, Vincent. Sure. My name is Roman.
Hi, Roman.
Pretty cool concept. First time really hearing about this. When comparing it to Databricks, because you can, use Databricks to not necessarily ingest, but, transform data in any type of way and then export it to, a data lake, even at that point. Mm-hmm. Is Azure Data Explorer a good alternative for that? Or is Databricks better at something like that?
Yeah, so it's a good question. So if you really do data engineering, like we have down here, Spark would be Spark in Synapse Spark Pool or Databricks would be better. So what I mean by that is if you have data in data lake, you just want to apply a transformation to move it, let's say, from a bronze layer to a silver layer. Databricks is really good at doing that. I wouldn't use ADX because you don't really beneficiate from having indexes and speedy queries. Where it's good at, if you have something, a lot of scenarios that I've seen, for instance, is customers having data coming in real time. So it's ingested into ADX. They run ad hoc queries either by API, so something automated, or ad hoc queries running by users. And on top of that, they run transformation as their data is ingested. So for instance, they might parse the data, they might split columns, and they might enrich the data from lookup tables that they have right, left, and center. What you can do in ADX is what we call a continuous export. So you can, once you ingested your data, you can export it back to the data lake at constant time, like frequency, let's say every hour or every time there's 200 megabytes of data. So you can trigger an export like that. So there is a sort of an intersection between the two. But if you really do data engineering a one-time, one-shot deal, I would use Spark. If you do something more real-time and querying as you go, I would use ADX, if that answers your question.
Yeah, definitely did. Thanks for that.
Yes.